Hello, everyone. Today we're going to do a packet tracer of CCNA 3 version 6.2.7. Packet tracer investigate NAT operations. This is addressing table. Objectives. Part 1, investigate NAT operation across the intranet. Here's intranet. Part 2, investigate NAT operation across the internet. Here's internet. Part 3, conduct further investigations. Scenario: as a frame travels across the network, the MAC addresses may change. IP addresses can also change when the packet is forwarded by a device configured with NAT. In this activity, we will investigate what happens to IP addresses during the NAT process. Instructions. Part 1, investigate NAT operation across the intranet. Step 1, wait for the network to converge. It might take a few minutes for everything in the network to converge. You can speed the process up by clicking fast forward time. Yeah, look at the topology. The network is converged because all these little triangles turn green. These little triangles are the interface light. When they all turn green, that means the network is converged. If it's not, you can click this button, fast forward time button, to speed up the process. Step 2, generate an HTTP request from any PC in the central domain. Any PC in the central domain. This is central domain. And there are 3 domains. So this is home office domain. And this is branch domain. All right, so any pieces from central domain. So we take PC1. Switch to simulation mode and add it to the filters to show only HTTP request. Here's simulation mode. All right, here is HTTP already. And we start from beginning, show all or now. So show now, this is show all, the show now. Okay, we get HTTP. HTTP is in the miscellaneous MISC here. It's HTTP, we click it. All right, so HTTP shows up here. Open the web browser of any PC in the central domain. So we open PC1, web browser, and type the URL, this URL, and click go minimize the browser window. Okay, it's HTTP / branch server PKA branch server PKA, go and minimize browser window and click capture forward until the PDU is over D1 or D2. Okay, we can click either this button or this button. Either one is okay, is good. So I close this window and click here, click. Okay, the PDU shows up on PC1. We click from PC1 to S1, from S1 to D1. Yes, over D1. Okay, good. So we stop here and click the PDU and I record the source and the destination IP addresses. Source and destination IP addresses. Let's record it. So here, the source is PC1. The source IP, the 10.2.0.4. From the number, we can tell this is a private IP address. This is a private address of PC1. So we record it here, private, PC1 private, 10.2.0.4. Okay. And the destination This destination IP is 64.100.200.1. This is supposed to be the branch server's public address, because the 64 is a public address. 64, 100, 200 to 1 is here. Yeah, this IP address is located on R4, but it is the public address of branch server. All right, so it's recorded. Branch server public 64.100. Oh no, sorry, 100.200.1. Branch server public. Okay. And to what devices do those addresses belong? And this address 10.2.0.4 belong to PC1. It's PC1's private address. And this address destination 64.100.200.1 is public address of branch server, but it's located on R4. Okay, so keep going. Capture forward on 2 PDU over R2. R2. Okay, click. Okay, then stop here. It recorded the source and destination IP addresses in the outbound packet. Outbound is out layers is outbound. In layers is inbound. Okay, let's record the source and destination IP address. Here, 64.100.100.3. This is the source IP. Source IP is supposed to be the PC1's public address. PC1's public address. R2, 64.100, 100 and 103, but here's 2. Okay, so this is the PC1's public. PC1's public, let's record it. 64.100.100.3. That's PC1's public address. And this is still the same as this one. It's a branch server's public, 100, 200.1. All right. R2, we're on to R2. What devices do those addresses belong? This is PC1's public address, but it's located on R2. This destination IP is public address of branch server located on R4. Okay. Log into R2 from CLI using the password class to enter privileged exec and issue the following command. It should run include pool. Let's click R2. Enable class. All right, so show run pipe include pool. Oh, okay, here. IP NAT pool, the R2 pool. The R2 pool is the name of the pool, and followed by a range, address range. Address range start from 64.100.100.3 to 64.100.100.31. This is the address range in this pool. Okay, and this IP18 set source leads to one pool R2 pool. This is a configuration of the pool, NAT pool. Okay, the address came from the NAT pool, R2 pool. R2 pool. Okay, look at here. this is 64.100.103 is public address of PC1. This address is come from this pool, R2 pool. See, 64.100.103. So this is the first address of this pool. So this PC1's public address is coming from this pool, R2 pool. Okay. Finish here, F. So click capture forward until PDU is over R4. R4 is here. All right. R4. Let's go to R4. Okay, we stop here. And to see recorded the source and destination IP addresses in the outbound packet. So on R4 source IP address 64.100.103. 64.100.103 is this is the PC1's public address, and 172.16.0.3. This is the private address of a branch server. Branch server's private address. So let's record it here. Private, the branch server private 172.16.0.3. Okay, we record it. Okay, to what devices do those addresses belong? This address is PC1, it's public. This is branch server's private, belong to private branch server. And next, G, keep going. Capture forward until the PDU is over branch server.pka. So to here, okay, let's go. S4, and from S4 to branch server.pka. All right, so recorded the source and destination PCT port addresses. PCT port addresses. Okay, let's click in the outbound segment, outbound. All right. So here, TCP source port is 80. Destination port 1025. So source port 80 supposed to be branch servers. Okay, it's branch servers. Destination 1025 is PC1. Okay, let's look at this. In layers would be easier to understand. The source ports. You can imagine now you stand in front of the interface waiting to enter branch server, but it's still not enter yet. So at this moment, the source port still the PC1's port. So 1025 is PC1. The destination 80 is branch server's port. So here out there is the package enter the branch server inside already. It's trying to coming out from branch server. So the source port 80 is branch server itself. The destination is PC1. So the source and destination port inverted. All right, so 80 is branch servers. PC1 is 2020. Okay. Okay, we can do this now. So on both R2 and R4, run the following command and match the IP addresses and ports recorded above to the correct line of output R2 is blue. Show IP and NAT translations. Let's to see match. Okay, so here 10204. So from R2's perspective, inside is PC1. 10204. The inside local is private, global is public. So here is the private address of PC1. So here 10204. 64, 100, 103 is public address of PC1. The port number is 1025. Here, 1025. And this 201 is destination. Outside is destination. Inside is source. So here is the public address of branch server. Port number 80 here is matched. What do the inside local IP addresses have in common? Let's do the R4 to enable class show IP and NAT translations. Yeah, here from R4's perspective, inside is branch server. Here's inside branch server, but it's from R4's perspective. Okay, so here's branch server inside. Here is a private number. This is 200.1 is the public address of branch server. 80 is the port number, 80 port number. Okay. So all these inside the local IP addresses have in common is they are private IP address. So did any private addresses cross the intranet? No. No, from PC1 to branch server, the private address is translated on R2 and R4. So no private IP address cross the intranet. Okay, so next click the reset simulation button and remain in simulation model. So here, reset, here's edit, simu reset. Okay, so the simulation panel become empty. So we can start the next part. Part investigate NAT operation across the internet. Step 1, generate an HTTP request from any computer in the home office. There's home office, any PC, any computer in home office. So open the web browser of any PC. We take a home desktop. Go to the web browser. Okay, here, web browser. And type the URL, centralserver.pka, HTTP, centralserver.pka, centralserver.pka. Okay, go and minimize. Then click capture forward until PDU over WRS. WRS router is here. So let's go. Okay, PDU show up. And go to WRS router and record the inbound source inbound source and destination IP address and the outbound source and destination address. Okay, so both inbound and outbound source and destination IP address. So record, let's record. Here 192.168.0.101. Yeah, when we look at this number 192, we know it's a private IP address of source home desktop. So we can record it here. Private home desktop private number is 192.168.0.101. Destination 64.100.102. Supposed to be the central server's public address. Central server's public address. R2, 100 and 102 is here. 100, 102. Yep, it's on R2. So it's a central server's public address. Public central server. 64.100.100.2. Okay, this is the source destination inbound. Source 64.104.223.2. This is supposed to be source, the home desktop's public address on R4 here. 2232 is here. This address on WRS. WRS translates the private address into public address. Is here. This one is public. So this is the home desktop public. 64.104.223.2. Okay, so here's 100, 102. This destination is 102 is central server's public. All right. Okay, we go to the WRS recorded and device to what devices do those addresses belong? Yeah, I said already. Yeah, this is the public. This is a private IP address of home desktop. This is the public address of home desktop. This is the public address of central server. This is the same here. These are the same central server's public address. Okay, so click. Click capture forward until PDU is over R2. So R2, then go to another from WRS to R2 and cross internet to enter another remote network. Okay. Go to internet. Okay, and go to R2. Okay, stop here. R2. Record the source and destination IP address in outbound packet. All right, record. Here, outbound. Outbound 64.104.223.2. Okay, this is the public address of home desktop. Home desktop is here. And this destination IP address 10.10.10.2. Yeah, from 10, we can tell it's a private IP address of a central server, because destination is central server. So central servers private is 10, 10, 10, 2. All right, 10, 10, 10, 2. Okay. And to what devices do those addresses belong? Yeah, this is belong to is home desktops public and located on WRS. This 10.10.2 is central servers private IP. All right. So on R2, run the following command and match the IP addresses and the ports recorded above to the correct line of output. So show IPA NAT translation. So up arrow. Yes. Yeah, match. It's match here. 64. Yeah. Yeah, from R2's perspective, inside is central server. Central server. No. Yes, central inside. 192. So home desk to central server. 192, 192. 64. Oh yeah. Oh, here, this is the 4. Oh yeah, this is PC. This is PC1. It's from R2's perspective, the inside is central server. So 10.10.2 is a local. It's a private. Yeah, here is private. So 102 here is the global public. The outside is home desktop. This is the public address 223.2. Okay, matched. Okay, so it's around real-time mode. Okay, did all the web page appear in the browsers? Let's try. PC1, yes, appeared. The web pages appear. Branch server from PC1 to branch server. And this one is from home desktop to central server. Yeah, it's correct. So we finished part 2. Now let's move forward to part 3, conduct further investigations, experiment with more packets, both HTTP and HTTPS, and answer the following questions. Do the NAT translation tables grow? Let's go. Okay, so because we did HTTP already, so now we do the HTTPS. So from PC1 to branch server. So this time we do HTTPS. Okay. Let's come out and getting. All right, HTTPS. Go. Yes, branch server. Good. So from home desktop, HTTPS this time we do. Okay. Let's come out and getting HTTPS. Go. Central server. Yeah, the web page appears. All right. And then we do the show IP NAT translation. Good. So the question is, do the NAT translation table grow? Yes, grow. And look at here, the 443. The 443 is, this port number 443 is for HTTPS. The port 80 is for HTTP. Does WRS have a NAT pool of addresses? Let's go to WRS router. Let's go to status. Here, this address, 64.104.223.2. That is the public address. This one, this address is the public address of home desktop. So there's only one public address here. That means all the under devices in home office domain will use the same public address. This public address, 64.104.223.2, as their public address. Next question, is this how the computers in the classroom connect to the internet? Okay, so in order to answer this question, we need to go to Google. You guys can go to Google and search what is my IP address. So from your computer, they will show your computer's IPv4 public address. If all the students have the same IPv4 address, that means all the computers in the classroom use the same public address. If some students have the different IPv4 public address, that means the router has multiple public address in the NAT pool for the students to enter internet. To use this, what is my IP address? You will find out. And why does NAT use 4 columns of addresses and ports? Here, the 4 columns. Why? Because it needs 4 columns to show the inside global, inside local, outside local, outside global. Okay, inside global is inside public. Inside the local is inside private. Outside local, outside global. Right. And the ports they use like a 1025 and 80 like this. The port used is to identify the device from which the packets originated. Okay, next question. Where are the networks are inside global and inside local? Here is inside local, inside global. Okay, on which devices are NAT service operating? What do they have in common? All right, so these 3 routers, router R1, R4, and WRS, these 3 routers operate the NAT services. The common they have is they have the NAT table to translate the private local address into the public IP address. All right, so we are done for this package investigate NAT operations. Thanks for watching my video. If you like my video and think it's helpful for you, please thumbs up and share with your friends and subscribe my channel as support. See you next time.